The temperature of coffee in a cup at T minutes is modeled by a decreasing function C, where C of T is measured in Celsius. For 0 less than or equal to T less than or equal to 12, select values of C are given in a table. Very typical. You've seen lots of these during the year. Instead of giving you the graph or the equation, you just get a small snippet of information, which is kind of a nice way of looking at it, because if you do any kind of research in science or in other things, often you only get a small set of measurements that you've done. Well, what can we do with those measurements? So here we want to approximate C prime of 5 using the average rate of change of C over the interval from 3 to 7. So if we're doing the average rate of change, and we don't have the rate of change equation, now we're just finding that slope of that secant line. So we look at C of 7 minus C of 3, so that'll be the 85 minus the 69, divided by the change there, 4, and we can assume it's going to be minus 4 degrees Celsius per minute. Now our Riemann sums use a left Riemann sum with 3 subintervals. So here is interval 1, here's interval 2, there's our interval 3. 3 subintervals to approximate the value of the integral from 0 to 12. So what are we going to do? We're going to make rectangles. We're going to make rectangles. The green rectangle would have a width of 3, the blue rectangle a width of 4, and the purple rectangle a width of 5. And since it's the left Riemann sum, for the green rectangle, whoops, that's not green, wait for it. The green rectangle, we'll use that one. The blue one, that one, and the purple one. So we're using the left height to make our rectangles. So if I color code our numbers here, this is the green one, this is the blue one, and that's the purple one. So we make a rectangle, 3 rectangles, and it's the left one, so the height will be the left values, and we get 985. Interpret the meaning of 1/12 of that integral in context of the problem. And so recognizing that this is the average temperature of the coffee. Okay, so noticing that this from 0 to 12 and a 1/12 out in front is the average of a function. Which function are we taking the average of? We're taking the average of C of T, which was the temperature over the interval from 0 to 12. So again, this was from the 2024 exam. So just seeing how they ask different things within the same question. We went from a Riemann sum to an average of a function. And then from 12 to 20, the rate of change of the temperature is modeled by this, C prime of T, where C prime of T is measured in Celsius per minute. Still got the same chart there. Find the temperature of the coffee at time equals 20. So what do we know? We know at time 12, the temperature was 55. And if we integrate a rate, that always gets us our accumulation of change. So if we integrate the rate from 12 to 20, that will tell us how much the temperature has changed from 12 to 20. And since we knew the temperature at 12 was 55, if we just say 55 plus how much it's changed, apparently it went down about 15 degrees over that time. And often you'll see this, you'll say, show the setup for your calculations. Why? Because it's a calculator. You actually don't have to do any math. You just have to type things into your calculator and get an answer. So they want to see the setup, and then if your answer is wrong, they're like, okay, they know what to do, they just don't know how to use their calculator. I would say this is quite typical of seeing something on exam, this idea of you have a value and then the integral of a rate being that accumulation of change. We've seen it a fair bit in the questions that we've done. You'll see it on your exam reviews quite a bit. This is, I can't tell you for sure what's going to be on the exam, but this happens a fair bit, this idea, in the long answer. Everything else, multiple choice, you'll see a bit of everything from all the units there. But for the long answer, which are worth a little bit more, this is a common idea. So in the model in part C, they give us the second derivative from 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. So what are we trying to, we're not trying to figure out if the temperature is decreasing or increasing. We're trying to figure out if the rate of the temperature is increasing or decreasing. So reading these questions carefully sometimes requires reading them 2 or 3 times, just like, what are they asking for? So if I look at this second derivative, okay, between 12 and 20, if we analyze it, do you see that t squared, that will always be positive. 100 minus t between 12 and 20, that would always be positive. And e to any exponent is always positive. The only thing we don't know if it's 0.245. I don't know. I think it's positive. Okay. So we'll just draw a happy face. That's positive as well. Everything is positive, so we can say that because the second derivative is positive on this, the rate of temperature of the coffee is increasing. Okay? So that means that the temperature of the coffee is changing at an increasing rate. What can we say about the original function? The original function then would be concave up, right? So this kind of stuff is sort of increasing, decreasing, first derivative, second derivative. That gets to our curve sketching kind of ideas and connects that unit as well.